Hello, welcome to CET 4884 Security Methods and Practice. In this session, we will continue our discussion on firewalls addressing content filtering, and we will address the remote access concept, and we will also address virtual private networks. A content filter is a software filter, technically not a firewall, that allows administrators to restrict access to content from within a network. It's essentially a set of scripts or programs that restricts user access to certain networking protocols and internet locations, or restricts users from receiving general types or specific examples of internet content. Some refer to the content filters as reverse firewalls, as their primary focus is to restrict internal access to external material. So actually you're blocking the users from the inside to get to the outside. For example, in a company, the most common implementation for this model or for the content filter is blocking the company's employees from using Facebook or using their private email or other social networks during work. The rating is like a set of firewall rules for a website and is common in residential content filters. Usually it's called rating and filtering, which is one of the components of the content, or the two components of content filtering. The filtering is a method used to restrict specific access requests to the identified resources, which may be websites, servers, or whatever resources for the content filter administrator configures or see that it's important to block from the internal user. The most common content filters restricts user from accessing websites with obvious non-business related materials, such as like I said, social networks, or spy emails or other restricted websites. Installing internet connections requires using leased lines or other data channels provided by common carriers, and therefore these connections are usually permanent and secured under the requirements of a formal service agreement between the company and the provider. In the past, organizations provided remote connections exclusively through dial-up services like remote authentication services, or RAS. Since the internet has become more widespread in recent years, other options such as virtual private networks have become more popular. The dial-up is a widely held view that these unsecured dial-up connection points represent a substantial exposure to attack. An attacker who suspects that an organization has a dial-up lines can use a device called a word dialer to locate the connection points. A word dialer is an automatic phone dialing program that dials every number in a configured range and checks to see if a person answering machine or the modem picks up. Some technologies such as radius systems or TACACS, TACACS, and CHAP password systems have improved the authentication process. Radius and TACACS are systems that authenticate the credentials of users who are trying to access an organization's network via a dial-up connection. The remote authentication dial-in user service system places the responsibility for authentication each user in the central Radius server. When a remote access server receives a request for a network connection from a dial-up client, it passes the request along with the user's credentials to the Radius server, which then validates the credentials and passes the resulting decision, accept or deny, back to the accepting RAS. Similar in function to the Radius systems or system in the terminal access control system, controller access control system, which is the Ch6, and it's like Radius is a centralized database and validates the user's credentials at this TACACS server. Diameter in an emerging alternative derived from the Radius. This figure shows the Radius configuration, and as we can see, the remote access, the RAS server in the middle. So the remote worker dials the RAS and submits username and password. The RAS passes username and password to Radius server, and Radius server approves or rejects request and provides access authorization. The RAS provides access to authorized remote workers, and by this you get, or the worker get, access to the information in the server. Kerberos can be used to secure authentication. Kerberos uses semantic or symmetric key encryption to validate an individual user to various network resources. The Kerberos keeps its Kerberos, which keeps database containing the private keys of clients and servers. In the case of a client, this key is simply the client's encrypted password. The Kerberos system knows these private keys and can authenticate to one network node, client or server to another. Kerberos consists of three interacting services, all of which uses the database library. The authentication server, the AS, which is a Kerberos server that authenticates clients and servers. The key distribution center, KDC, which generates and issues session keys. And the Kerberos ticket granting service, which is TGS, which provides tickets to clients who request the services. Let's go back a little bit, and in Kerberos, a ticket is an identification card for a particular client that verifies to the server that the client is requesting services and that the client is a valid member of the Kerberos system and therefore authorized to receive services. The ticket consists of the client name and network address, ticket validation starting and ending time, and the session key, all encrypted in the private key of the server from which the client is requesting services. And this is this figure shows the Kerberos login, and you can see that the user logs into the client machine, and then the client machine encrypts password to create client key, and then the client machine sends clear request to Kerberos TGS, and Kerberos TGS returns ticket consisting of the client TGS session key for future communication between the client and the TGS, encrypted with the client's key, and the ticket granting ticket, which is TGT. The TGT contains the client name, client address, ticket valid times, and the client TGS session key, all encrypted in the TGS private key. This figure in this slide shows the Kerberos request for services, and you can see how the client requests the service, which goes to the Kerberos TGS, and then a response comes back from the server to the client back. The secure European system for applications in a multi-vendor environment, which is called Sesame, is similar to Kerberos in that the user is first authenticated to an authentication server and receives a token. The token is then presented to a privilege attribute server instead of the ticket granting service as in Kerberos as a proof of identity to gain privilege attribute certificate, or what we call PAC. Privilege attribute certificate will be issued to be given to the client or to the token. Sesame also builds on the Kerberos model by adding additional and more sophisticated access control features, more accessible or more scalable encryption systems, as well as improved manageability, auditing features, and the delegation of responsibility for allowing access. For the virtual private networks, which is a private and secure network connection between systems that uses the data communication capability of an unsecured and public network. The VPNs are commonly used to extend securely an organization's internal network connection to remote locations beyond the trusted network. The VPNC defines three VPN technologies. A trusted VPN or VPN uses leased circuits, so it's leased from a service provider and product packet switching over these leased circuits. Secure VPNs are security protocols and encrypt traffic transmitted across unsecured public networks like the internet. A hybrid VPN combines the two, providing encrypted transmission as the secure VPN over some or all of a trusted VPN network. A VPN that proposes to offer a secure and reliable capability while relying on public networks must address first, the encapsulation of incoming and outgoing data, wherein the native protocol of the client is embedded within the frames of a protocol that can be routed over the public network, as well as the usable by the server network environment. And then encryption of incoming and outgoing data to keep the data content private while in transit over the public network, but usable by the client and server computers and or the local networks on both ends of the VPN connection. And then the authentication of the remote computer and perhaps the remote user as well. Authentication at the subsequent authorization of the user to perform specific actions are predicated on accurate and reliable identification of the remote system and or user. In transport mode, the data within an IP packet is encrypted, but the header information is not. This allows the user to establish a secure link directly with the remote host, encrypting only the data content of the packet. There are two popular uses for transport mode VPNs. The end-to-end transport of encrypted data. In this model, two end users can communicate directly, encrypting and decrypting their communications as needed. Each machine acts as the end node, VPN server, and client. And in a remote access worker or teleworker that connects to an office network over the internet by connecting to VPN server on the perimeter. This figure shows a transport mode VPN, and as you can see, this is the teleworker client machine sending to destination system with the unencrypted header, and then it will go through the untrusted network to the VPN where it authenticates and give the authorization, giving access to the encrypted data. In tunnel mode, the organization establishes two parameters tunnel servers. These servers serve as the encryption or the encryption points, encrypting all traffic that will transfer or traverse an unsecured network. The tunnel mode, the entire client packet is encrypted and added as the data portion of the packet addressed from one tunneling server to another. The receiving server decrypts the packet and sends it to the final address within the internal network, the trusted network. The primary benefit to this model is that an encrypted of course, when it's intercepted, when the packets are intercepted, it reveals nothing about the true destination system or the information included. This figure shows the tunnel mode VPN. As you can see, the VPN that is from a certain client side is communicating with the VPN from the server side through that virtual tunnel. So that will be all for this session. Thank you and have a great day.